everyone. My name is Carol and I'm here with Nasis who'll be telling us more about Intro to Speech and Text Service in NLP. Hi Nasis, how are you?
Hi Carol, I'm good, and you? How are you doing?
I'm good. Long time, hey?
Yeah, it's been a long time. It's been a while since we've had a pre-recorded service. Episode.
Okay. How was your day and how is your weather? How is your 2023?
So far it's going well. I can't complain. We're just taking it day by day. All I can say is I'm excited to be here once again and sharing content as we do weekly.
What will you be telling us about today?
So today we'll be building upon what we've been doing for the first few episodes of AI Tuesday. We've been focusing on natural language processing, translation, text analysis. Now we'll be moving on to speech recognition, basically. How natural language processing handles speech and how it deals with speech recognition, basically. And then we'll take it from there. That's what I can say for today's episode.
Looking forward to the presentation for today. The floor is yours.
Thanks. So let me just share my screen so we can start presenting. So as I was saying in the introduction, that we'll be building upon what we've been doing for the past few sessions on AI Tuesday. So just a bit of a recap before we actually start with today's episode. So just a recap. It's not playing well. Let me share my screen again. Okay. Is my screen visible?
Yes, it's still loading.
Okay, cool.
So think about this. How often are you alive? When the dawn of a new medium comes out, I knew that I had to be a part of VR because there are no rules for what VR should be. Starship Commander is a choose-your-own-adventure VR narrative that uses natural language processing, so you can actually have a real conversation with the characters.
I'm Sergeant Sarah Pearson. I've been assigned to your wing today.
When we started making Starship Commander, we had to figure out, how do we get technology that can understand what a person's saying so that we can have these new narrative experiences? We're a science fiction game. We come up with new words. No off-the-shelf software could let us put in custom words.
Who are the Echnians?
In our story, the bad guys are called the Echnians. And every time we said Echnian, it would come up with really weird words that were similar to other things that you would say. And so it would get confused all the time. So we needed to make sure that we could supply our own script. We started using Microsoft Cognitive Services to power the backend of Starship Commander.
Looks cool.
Once we plugged custom speech service into Starship Commander, I had tears in my eyes when I was playing it because it's like, oh my God, this is it. This is the experience we want. Open the hatch.
Voice print accepted. Welcome, Commander.
You can essentially put your script in there and it knows, oh, these are the ways that people are going to talk. And these are the phrases that they're going to say.
Cool. What's my mission?
It must be something pretty important.
And then the second thing, too, was the intent detection. With Lewis, you basically give it a couple statements. After you've given it a couple statements, you crunch it and you start typing in your own statements. And it's shockingly scary how good it picks up, even stuff that you didn't put in there.
Computer, use autopilot and let's be on our way.
Autopilot engaging.
I've never seen an opportunity like this where there's a wide open playing field. No one's written the rules yet. There's going to be tons of amazing software out there, and I just can't wait to see what other people write.
And there you go. I know I've played this video a couple of times now, but the reason why I always play this is because it's easy to refer and to give a clear picture of what we're actually doing. So in this part of the video, the part that I'd like to focus on today's session is about the speech recognition, the fact that you are able to tell something to the game and the game gives you a response. You know, when they said things about the acnians and things like that, you are speaking to the game itself and giving you a response. And now in this episode, we're gonna go in more in depth to discover how exactly the game is able to recognize what you're saying and how is it able to respond back to you. So that's what we're going to be covering in today's session. And while I'm at it, there's this Microsoft Learn Student Ambassador. Don't forget to apply and visit our website so that you can join this awesome program. Just letting it out there. So moving on to today's topic, introduction to speech and text services in natural language processing, right? So like I said, we're still doing a recap. What is natural language processing? It's basically the process done by devices, machines, or gadgets to understand the human language or to understand human interactions via speech, via text, via even sign languages as well. This is a way of machines trying to understand what humans are trying to say. That's in simplicity what natural language processing is all about, right? So as still part of our recap, because it's been a while since we've done this, natural language processing, the core elements of natural language processing include the ability for it to analyze and interpret text in documents. That's text analysis, which you covered in previous episode. Interpret spoken language and synthesize speech responses. That's how we did in translation. Automatically translate spoken or written phrases between language. Again, part of translation. And interpret commands and determine appropriate actions. So that's what we'll be covering in the last part. Interpret, command, and determine appropriate actions. So you're wondering why I'm going too fast is because we're trying to cover today's session. But if you want more in-depth analysis of what I'm just spoken about, you can go back to previous episodes. So moving on, right? Natural language processing in Microsoft Azure. So we've covered text analytics, translator text, speech, and language understanding intelligence servers. So these are the 4 services that Microsoft Azure offers to people if they want to get started with NLP, right? So we've covered text analysis, we've covered translator text, we've covered speech. We're now going to be covering speech, the speech part of things. And then last but not least, in future episodes, we're going to tackle Lewis, right? So let's get started with speech, right? So speech and text services is a service that enables interaction between the AI system to have the ability to detect and interpret spoken input and also generate spoken output. So it has to be able to hear and understand what people are trying to say, and also must give some kind of response. That's speech synthesis. So now the services that we're going to look more into, or the technology that we're going to look more into, is speaker recognition, intent recognition, keyword recognition, speech translation, text to speech, and speech to text. So all these services all these technologies that I've just mentioned are responsible, the core front of making speech recognition work, basically. So again, I'm going to emphasize that how speech recognition works, there's 2 aspects to it. Speech recognition, the ability for it to detect and interpret spoken input, and then speech synthesis, the ability to generate spoken output. And to make these 2 work, we have speech recognition, intent recognition, keyword recognition, speech translation, text to speech, and speech to text. So those are the technologies that make speech recognition work. Let's go more in depth into it, basically. First up is recognize and synthesize speech. So, right, the device is just a device. How is it actually able to give us speech? How is it able to respond to what we're trying to say? So if I take my phone and say, hey Siri, what's the weather? Or hey Google, what's the weather? How is it able to respond to me what actually the weather is? So again, in previous episodes, if you want more better context, we spoke about a format in which the technology or the device puts it into it puts the spoken output. Or okay, let me rephrase it. So every time we speak or say something, it gets taken into a microphone. So the device microphone takes what we're trying to say, and then it puts it into a format that it's able to understand, and it breaks down what we're trying to say, and then it takes up the important parts of what we're trying to say and gives us a response from it. So from the example that I put, what is the weather? The words that I spoke, what is the weather, goes into the microphone of the device. From the microphone of the device, it gets put into a format that it will be able to understand. So in that format, you'll be able to understand. It breaks down what is the weather. So weather, what. So it breaks down all those keywords. After breaking down those keywords, and it then goes and searches for what actually the weather is. And then after that, it takes the response, put it into a format that it's able to understand, and then it gives an output. So it synthesizes speech from the response that it got. So basically, that's what speech synthesis is. It's the ability to produce speech. And how exactly it's able to do that? It basically uses models. So basically, this is now part of linguistics, whereby we talk about phenomes, we talk about algorithm, we talk about phenomes, we talk about phenomes. So, like if you look through the slides, speech recognition is concerned with the spoken word and converting into a data that can be processed. So basically, it transcribes what we're trying to say, and then it's in a text representation, and then it puts it out into a recorded voice or audio format, as I've just explained in simplicity. So how exactly it's able to do that? It says an acoustic model converts the audio signal into phonemes. So basically, phonemes relates to the representation of specific sounds, if you don't know what phonemes is. And then a model maps those phonemes into words using statistical algorithms that predict the most probable sequence of based phonemes. So basically, it uses phonemes. So basically, what it's trying to say is that so as it takes the spoken output, like the weather, for example, it puts it into specific phonemes, like specific sounds, like the way I'm able to pronounce A, B, B, C, D. It puts that in those specific sounds, and then the model puts that into sound for us to hear, into a format that we're able to hear. So that's in a nutshell how speech synthesis works exactly. Moving on. So more in depth about speech synthesis. So it starts with the text to be spoken, and then the voice to be used to vocalize the speech. I don't know if you remember in the previous episode, we spoke about that we can make our actual virtual assistant using Microsoft services in the previous episodes as well. So you can choose your voice that you want, and then on top of it, it breaks down, as it says, it breaks it down into individual words and assigns phonetic sounds to each word. So basically, I don't want to go through all of this, but in a nutshell, to understand how speech synthesis works is that it takes the format, it puts it out into specific words. How is it going to pronounce this word? How is it going to pronounce that word? And then there's an algorithm that will take what's being put out there and put it into an audio format. That's simply how speech synthesis works. And we can use it to generate responses to user input. We can create voice menus for telephone systems. So I don't know, when you call MTN, Vodacom, that lady that responds to you, that's one of the speech synthesis services they use. Reading email or text aloud in hands-free scenarios, and broadcasting announcements. So these are some of the places where speech synthesis is being used. Now, we move on to speech recognition or speaker recognition. So speaker recognition basically has to do with memorizing someone's voice. So on your phone, there's this type of security whereby you can unlock your phone by saying specific words. In smart houses, those people with smart houses, they can just say open door, open window, and the door opens and the window opens. But how is it able to do that? Because it recognizes the speaker's voice. So when you get your new device or when you get your new smart house, whichever device you're dealing with, it's going to ask you to speak into it several times so that it's able to recognize your voice. So that every time you speak to it, it's not going to match. So this voice that I have in my database or this voice that I have saved, is it the same one as if it's coming in? If it's not the same one, it won't execute an action. But if it's the same one, if it's an exact match, then it's going to execute the action. Basically, that's what speaker recognition is all about. As you can see in the small diagram that I've put. So enrollment audio, it's you who's speaking the voice. It's basically you putting in a voice that you want it to remember, and then it captures that voice basically. So now if it's the wrong voice, it's gonna give you a mismatch. If it's the correct voice, it's gonna give you a match and it's gonna execute what you're trying to say. So to add on, speaker verification can either be text dependent or text independent, meaning it can be via specific words that you said or via a specific not word exactly, but specific sound or specific key. You know, everybody has their specific way of greeting one another basically. So you can also train your model to do such a thing basically. So moving on, keyword recognition detects a short word or a phrase within a stream of audio. It's also referred to as keyword spotting. So basically, if I say open door, so that's the secret keyword that I want my AI to recognize. I don't know if you go to also offices, like a big company offices, they in order for you to get into the office, they do an eye scan to see if you're the actual person, if it's then in their database. And then there's also a vocal. They want you to say something so that they're able to see if that person is really who they say they are. So it can be a secret keyword that the company knows or the business knows, etc. But it all falls under keyword recognition. For example, the keyword recognition that we use every day is Hey Google, Hey Siri, Hey Cantona. Those are the keyword recognition. So every time it hears those words, it activates, it pops up, it responds to you because of those keywords that you just put. So that's just an example. Speech translation. So speech translation is basically translating what you put into another in another language while being spoken. So for example, if I type in Zulu, then the speech translation is gonna translate whatever I want in English, basically. So that's what speech translation is all about. So it translates results in a spoken output. You can translate it text to text, whereby you read the text by itself, or by you want it to be output. You want to hear what it's gonna sound like, or how you want to hear how it's gonna feel like or sound like, if I can put it that way. That's basically what speech translation is all about. Its speech translation service enables real-time multi-language speech-to-speech and speech-to-text translation of audio streams. So basically, text to text, you can like put two texts there in one language and in another language, for example, English and Zulu, and it's gonna output that text over there. Or you can also, for example, if I go on holiday and I don't know Spanish or German, I don't know Spanish or German in the other country that I'm in, I can simply speak in English on my phone, and my phone will automatically translate it into that specific language which I'm looking for. That's an example of speech translation, right? Just to continue, how does it actually work? So you have to provide an audio, and then after you provide that audio, it transcribes whatever you're trying to say, and then it translates it. After translating it, then it converts it into a synthesized speech, as we spoke about earlier on. So that's basically how speech translation works. And then this again goes part to linguistics, where you have literal and semantic translation. For example, éteindre la lumière, right? Éteindre la lumière is in French for turn off the light, but it can also mean the same thing as fermer la lumière, meaning close the light. It doesn't make sense to say close the light. We say turn off the light, but in French, there's fermer la lumière. It doesn't make sense if you get what I mean. Fermer la lumière means turn off the light, right? Which means the exact same thing. But we won't say it because in French it doesn't make sense. So instead, we're gonna say éteindre la lumière. So éteindre la lumière is an example of semantic translation, right? Whereby it must make sense. But then fermer la lumière is an example of literal translation. So now when you're translating, you have to make your AR model or your AR model to be aware of these rules that they have to follow in certain languages, because in certain languages there are different rules. In English, and if you're translating from Zulu to English, there's different rules that you have to follow. So text to speech. So text to speech is basically taking a text input and putting into a speech format or an audio format. So it enables you to convert text it allows you to convert text into human-like synthesized speech. For example, I write hello, I type hello, and then and I press enter, it's gonna output hello as if it's an actual person, basically. So that's what text to speech is all about. And then opposite of speech to text, it's the opposite of text to speech is speech to text. So whereby you say something and then it transcribes it for you, right? So that's an example of speech to text. So to end off the theory part, which I didn't want to bore you with the theory part, we're gonna get started with speech on Azure. So there's some of the services on Azure. There's speech to text API, which you can use, real-time transcription, batch transcription, and then text to speech API, speech synthesis voice. So what do these all things mean? Speech to text API is an API that you can use to convert your speech into text, right? You don't have to code it by yourself, but it offers that service for you. Real-time transcription. Real-time transcription basically allows you to, as for example, Carol and I speak English, Carol speaks Zulu, and we don't understand each other. So with using real-time transcription, I'll speak in English, and then my device will translate it in Zulu for her. And every time she replies, it's going to translate from Zulu to English for me, so we are able to get an understanding. Batch transcription allows you to transcribe a huge document or huge chunks of text, basically. Text-to-speech API is basically an API that allows you to convert text into speech, and speech synthesis voice allows you to choose from a series of voices so that you can make your own virtual assistants, if I can put it that way. So I am going to end it off over here, and I'm going to go off to the to the demo. So there you go. I'm going to end off the presentation with this last slide point. I don't want to focus too much on theory, so I'm going to do a small demo presentation before we conclude today's episode. Before I show the demo, Carol, do you have any questions that you'd like to ask?
Narcisse, we heard you speaking more about phenomenons. I'm not sure if I'm pronouncing it properly, but can you please just explain more into it on what it is actually?
It is. Okay, cool. Let me just find it really quickly. Okay. So there is it over here on the slide. So basically, as I was saying, phenomenons, I'm also struggling to pronounce it. It has to do with linguistics, the linguistics part of things. It's like how something is being said or pronounced, basically, the gist behind pronouncing something. So over here, when it comes to speech synthesis or synthesizing speech, as it says here, the system puts or breaks down the text into individual words and assigns for phonetic sounds to each word. So the reason why it assigns these sounds to each word so that to be able to pronounce it. So to further elaborate on this, I'm just gonna also share another screen from our previous episodes that we've been doing on the voice gallery. So there's it over here, right? There's it over here. There's it over here. Yes, there's it over here. So remember when we are doing speech to text, we mentioned that as the text or whatever we're trying to say goes into the microphone of the device, it gets put into a format that it's able to understand. That format is called speech synthesis markup language, as we spoke about it in previous episodes. So now, just to put into an example of the phonetic sounds that I was mentioning, you can see that, look at this friendly. You see friendly, it means that he must speak in a friendly voice. How was your day at school? All this text, blue text over here, it's indicating how exactly the AI model or the speech must be spoken out or synthesized, basically. So that's like I said, it has to do back with linguistics point of view, but in a general nutshell, that's how it synthesizes speech, if I can put it that way. Does that answer your question, Carol?
Yes, it definitely did answer my question. Yes, now I understand better. Even with the illustrations, I understand better.
Okay, I'm glad to hear that. So I'm just going to quickly move on to the demo before we end today's episode. So the first thing we're going to do is first quickly go back to Microsoft Azure. That's where everything started. And then again, we're going to create our resource. I'm just going to quickly give you a quick reminder on creating the resources. So speech. So you just search for what type of service you're looking for. We are looking for speech services. I click on it and it's loading, it's loading, it's loading. And then there's the speech text service that I've already created. So remember, there's different types of speech text services that you can create. One you can create to synthesize speech, and the other one is to just analyze text, as we did in previous episodes. So we want both of them to analyze speech and also at the same time to give out speech as well. So that's what we'll be doing. So I won't go through how creating a resource on Azure. If you want to know more about that, I recommend you go to the previous episode. But what I'll be actually showing is the coding aspect of things, basically. So, right, here's a small program that I made, basically, whereby I'm going to say something and then the computer or the AI model is going to transcribe it for me. So this is speech to text, right? So I'm going to say something, it's going to go through my microphone and it's going to record it. It's going to translate it for me, transcribe it for me, I mean. So let me quickly run it and then showcase it. Quickly run it before we go through the code. So as you've been seeing throughout the past few episodes, we've been seeing different ways of making application. So it says, if you can read here, it says speak into your microphone. Let me just zoom it in. So do you see that, right? Let me zoom it in. Okay. So can you see the text, Carol?
Yes, I can.
So what I just said right now, past few episodes, I've been seeing different ways of making application. So it says that you can read essays, speak into your microphone. Let me zoom it in. So everything that I just said got picked up by my microphone and got put into the text in text format. So this is speech to text, basically. So I'm just going to close the program here quickly and then go through the code to end off today's episode. So the first thing that we had to do is to get our environment. To get your environment. So this is a console application, a very simple application that you can make using code. Remember, there's different ways of making code. You can use no code or low code the Power Platform basically. You can hire someone to do it for you, or you can do it by yourself by using a console application. So this is like the professionals who are doing per se, right? So now the first thing that you have to do is to get your keys, your subscription key, and your region in which your resource is based on. So here's my resource that we created. So if I come back to Azure and then I just come to keys and endpoints, and there you go, right? You see it's blocked because you shouldn't share your key to anyone, and then the region in which my resource is based on, and the address of my resource on the internet. That's where it is. So you get those two details are there, and you put it inside your code, and then after that you write your code to use your keys, to use your resource on Azure to make it work basically. Then the next thing to do is there's three cases, right? The first case is to recognize the voice that's being spoken out. Then the second case is if the voice is not recognized, what should happen? And then the third case is if the person decides to cancel. So you have to think about three different scenarios in order for you to make this application. So the first case deals with if the voice is a match, then it gets saved. Remember, we spoke about it saving the voice first before you can do anything with it. If it's not match, then it's gonna output speech could not be recognized. And then if it's got canceled, then it's gonna show an error code basically, or some kind of message that it got canceled. So after determining your three cases in which you're gonna be dealing with, then you actually code the actual program. So like I said, this is already done for you. You just have to use it as it is. So the fact that you're connecting it to Azure, the thing that's doing all the work is the one on Azure, right? So you just have to call Azure, right? You call the resource on Azure. There's it as calling the resource on Azure, and then you put in the voice that you captured from your microphone or from the user, and you put it into Azure, and Azure does this thing, and all you do is just output the results that it gets from Azure, right? So that's what these three lines is basically all about. So speech configuration. So speech configuration, it's calling the resource, the service from Azure to come do its thing. And then after that, the results that it gets put into it gets saved into a variable. It gets saved somewhere, if I can put it that way. And then after saving it in that specific place, you output it. That's where we output. Speak into your microphone, and we output the results as well. Basically, that's how it works. So in a nutshell, to just explain all this Chinese or coding for those who are non-coders, the first thing is to determine your scenarios. The first scenario is if a person speaks into the microphone, what must happen? If they decide to cancel, what must happen? And if the microphone is not working or something's wrong with it, then what should happen? So those are the three scenarios that I must come up with. Then the next thing to do is, once you have your voice, what do? You can manually do it by yourself, but that's going to be too difficult. You're going to need some kind of expertise. So that's why you call your Azure resource, and you put whatever the voice that you captured from your microphone, you put into the Azure resource, it does its thing, and then it just outputs the results. So that's how this basically works. And this is just a simple example. There are more examples here on the speech studio on Microsoft Azure, which I've just showed here. I'm just going to quickly go back again. This is all responsible for speech to text. So you got speech to text services, real-time speech to text. As you're speaking, it's transcribing for you. And then text to speech, it takes your text and puts it into speech, and you get to choose from various voices as well. And then you got voice assistants for you to create your own voices. So this is for people who do not know how to code or do not want to get involved in coding. They can use this to get it done. And then there's also Power Apps, which we've covered in the previous episode, where we did an app without touching any code at all. That's for those who want to code but not touch a lot of code. And this is for like the experts, which I've just showcased right now. So that's where I would like to end today's episode. What do you think, Carol? Over to you.
I'm very happy. I love the explanation. You explained everything on point. Like, it was perfect. But I also wanted to ask, what is the difference between speech to text and text to speech?
Good question. So speech to text, right? It takes the speech, or like right now as I'm speaking, everything that I'm speaking goes into the microphone and it gets transcribed, right? It gets transcribed into a text format. And then a text to speech is the opposite of it. So basically everything that's been written, it's going to output that into words. So just quickly, a quick example to elaborate on your question. I'm going to run this application again, which you've just made. So it just picked up the last sentence or the last word that I made. I said, it's made. So it picked up that text and it transcribed it for me. So this is the text version of what I've just said. So now if we want to, if you want to say text to speech, then I'm just going to choose from the speech studio already, the preloaded things already, for us to see what it's all about. Hopefully the internet doesn't behaves. So as I said, text to speech is the opposite of it. So basically it takes whatever is already written down and gonna put it into an audio format using the SSML, speech synthesis markup language. So that's the format in which it understands. Taking awfully so long. Okay, it got loaded. You need to be patient. Okay. Yeah, so there is it here. It's loading. So here's Jenny. I'm just gonna choose Jenny and I'm gonna make her say something.
Many think that the people you list as references are already cued to say nice things about you, and there are so many other ways to get information.
So you see, Jenny said something, right? So now here's a book, right? A book that's been written down. We can actually make it say words. So here's an English audio book, and I'm just gonna play it. So here's the text
and Anna are back home from school.
And it's being.
How was school today?
Deciding speech.
I got a D in my maths test.
What?
Sarah got an E.
You need to study more. You can only watch TV at weekends.
No, Mom.
There are more important things in life than TV.
Mom and Dad exist the room.
So I think you get the picture of text to speech, the opposite of it.
Yeah, the whole storybook, yeah, made me get it.
Okay, no problem. So yeah, so just to add on for next week's episode. So next week's episode will be dealing with Lewis, language intelligence service. If I'm not mistaken, Lewis. Language intelligence service. So basically we'll be creating our own language using Lewis. So it's language understanding intelligence service. I got caught up with the word. So we'll be creating our own language using AI in the next week's episode. Thank you again.
Thank you so much for today, Nassis. We really did learn a lot. I learned more than, like, every time when I get your sessions, I learn something new about things my laptop or my phone can actually do. Thank you so much for the whole episode, and I'm really looking forward for next week.
Thank you again. May enjoy the rest of your evening, and also to the audience, don't forget to like, subscribe, and share. Until next time, see you guys.
Thank you. Bye.
Bye.